Welcome to the VibroOne Basic Operation tutorial. In this video, we'll cover the basics of how to set up your measurements and environment to get consistent, high-quality measurements with your Polytec VibroOne Laser Doppler Vibrometer and Radiant Technologies Precision Materials Tester. To begin, make sure that the Vision software package and the VibroOne panel software are both installed on your system. The Vision software package is available online, while the VibroOne panel software is included with your purchase. In the Vision software, open the Quick Look menu and find the Advanced Piezo task. We won't cover all the details of Vision and the Advanced Piezo task in this video, so consult the task instructions page and the main Vision manual as additional resources. For now, we'll show an example that will generate a butterfly loop. This example is just to show some of the parameters that you'll change for your measurements, but you can follow along if you wish. First, we set standard bipolar as the drive profile type. For this example, we set the max voltage to 20 volts and the period to 1000 milliseconds or 1 second. Our sample parameters are based on our sample, but be aware that you'll need to set this based on your own sample. We set our amplification to auto. We ensure that the velocity capture sensor is enabled, which is sensor 2. Then we move on to setting up the Polytec. We ensure that the VibroOne is selected instead of the IVS 500. We enter the Ethernet address of the VibroOne, which you'll find in the settings on the VibroOne itself. Once entered, we press the Read Polytec button and it will take a moment to communicate with the VibroOne. From here, we ensure that the two autoscale boxes are checked. Most of these settings will be left as default, and you can consult the task instructions page for further information. Back in the main setup page, we ensure that we only loop once for this example. Finally, on the Plot tab, we change our plot title and ensure that we're not plotting against time or field. On the VibroOne, ensure that the laser is turned on. With that, we run the measurement. As the test runs, we'll see the displacement and velocity move on the display. When the test completes, you can see the polarization and hysteresis loop as the top plot. The middle plot is the displacement, shown as a butterfly loop. Finally, the bottom plot is the velocity, which is relatively constant throughout this example. Now that you're familiar with the basic parameters, we can begin setting up the noise floor measurements. Noise floor measurements are an important component of successful testing, and will need to be run frequently as your environment changes. The main setting we'll change to set up these measurements is the drive profile type, which we'll set to all zeros. The other setting that should be changed is the period, and we'll provide guidelines for how to set this later. For this example, we'll use a 4-second test and show how vibrations can affect the measurement. The rest of the settings will be as we showed previously, and we'll simply run the test. When the sync light on the tester turns on, we knock on the table a few times and repeat this whenever the sync light turns on again throughout the test. The effect of the knocking can be seen in the measurement. First, we'll save the result to our dataset with the option in the bottom right. If you have not yet created a dataset, use the option to save a new one. Then, when we call back the measurement in our archive, we'll enable the plot versus time option. This very clearly shows at what point in the measurement the knocks occurred. On screen now are some guidelines for how to set the measurement period based on what noise you're attempting to isolate. Again, you'll need to make several of these measurements and change your environment until you're satisfied with the noise. Some of the changes you'll need to make to reduce noise may be obvious, such as turning off the room lights. However, there are less obvious considerations, such as people moving in the test area. Avoid any unnecessary movements while testing is ongoing. On screen now are some final reminders and considerations for noise floor tests. Pause the video as needed to read all the information. With the noise floor out of the way, there are a few more considerations for successful testing. Ensure that any probe station chuck, probe station, or metal table are grounded. Samples must also be isolated from a grounded chuck. To verify test connections prior to probing your devices, we provide 1206 ceramic capacitors on which you can perform initial testing. When probing your device, try to do so in a perpendicular orientation, as shown in this diagram. With that, you have all the tools you need to take high-quality measurements with your Polytec VibroOne.